Okay, in this video I'm going to continue on with exercise 4b of the book Fundamental Applied Mathematics. We're on page 107 and the question is 29. It reads, a man wishes to swim across a river 60 meters wide. The river flows at a velocity of 13 meters per second parallel to the straight banks. A man can swim at 5 meters per second relative to the water. If he heads at an angle alpha to the upstream direction and his actual velocity is at an angle theta to the downstream direction, and we're asked to show that we show an expression for tan theta. So I've worked ahead a small bit here because the first part of this question is quite easy. So I've just drawn my first bank, my second bank, the velocity of the man relative to the water, the velocity of the man and the velocity of the water. And I've just actually physically written the three velocity vectors there. And we know of course that VMW is equal to VM minus VW. So that's what this is here. Look, that's something which at this stage you're definitely confident with. So if you want to just look at it for yourself, pause the video please. But I'm going to continue on here. So in the exact same fashion as we've done in questions 24 to 26, I'm going to isolate the I components and the J components. So if you isolate the J components, you're going to get that 5 times the sine of alpha is equal to V times the sine of theta. Now we're trying to isolate the fact that we're looking for tan theta. So I'm just going to isolate sine theta. So we're going to get that sine of theta is equal to 5 over V times the sine of alpha. Alright, sine of alpha. That's the first part, and that's just isolating the J components. Now if we do a similar thing and isolate the I components, we're going to get that negative 5, the cosine of alpha, is equal to V times the cosine of theta minus 13. So I want to isolate the cosine components, so we're going to get cos of theta, or I want to isolate the theta components. So we're going to get the cos of theta is equal to 13 minus 5 cos alpha over V. Alright, so just bear with me and just note this down here. Alright. So of course we know at this stage, definitely at this stage, that sine over cosine gives you tangent. So basically I'm going to divide my two expressions. So the first expression says that sine of theta is equal to 5 over V times the sine of alpha. And number 2 said that cos of theta is equal to 13 minus 5 times the cosine of alpha over V. So I'm just going to divide expression 1 by expression 2, and that will give us straight away an expression for tan theta. So tan theta is equal to 5 over V times the sine of alpha, and we're dividing by a fraction, so it's the same as multiplying by the inverse of the fraction. So just turn it upside down and multiply, and you're going to get an expression which is the exact same as the one in the book, which is that tan theta is equal to 5 times the sine of alpha over 13 minus 5 times the cosine of alpha. That's correct. Alright, so that's the easy part of the question. Now the next part says, prove that tan theta has a maximum value when cos alpha is equal to 5 over 13. Now I'm going to prove this using differentiation. If you're looking at this video in your 5th year, then you're not used to differentiation yet, well that's fine. However, when you're coming to your 6th year, when you're in 6th year, you definitely have done a lot of differentiation, and coming up to exams, it will be second nature to you. So, if this isn't familiar, what I'd like you to watch is the following. Watch my video, What is a Function? And that's in my playlist called, The Introduction to Basic Mathematical Functions. And also look at my video called, it's something along the lines of Angle for Maximum Range. And that's in my playlist for That's in my playlist for projectiles. And if you look at both of those, you'll understand theory, and you'll see a quite thorough practical of use of theory for maximizing a function. So look, I'm just going to go straight into what we have here. We have found that tan theta is equal to 5 times the sine of alpha over 13 minus 5 times the cosine of alpha. And this of course is a function which I'm going to call f. On the left we have a function f is equal to an f of theta. So it means it's variable, or it's its the ingredient for the recipe is theta. However, the ingredient also, it's a function of alpha, because of course the numbers 13 and 5 are constants, so in order to change the value of this expression we just need to change alpha. So we'll say the recipe is F and the ingredients are theta or alpha, and this is the actual recipe here itself. So what I'm going to do is differentiate my recipe, or my function. I'm going to go dd alpha, because I want to differentiate it with respect to alpha, of my function f of alpha, and I'm going to set that equal to 0. And if you do that, you'll find out what is the maximum and minimum values of your function. Now, unlike other examples I did of this, we actually have a quotient, or something divided by something else. So if I call the top line u and the bottom line v, we have to differentiate with respect to alpha. That's what dd alpha means, u over v. Alright, so look, it's just a rule. You just follow. It's called the quotient rule, and it's vu prime minus uv prime over v squared. Or if you want, you could write it as follows. You could write v times du d alpha minus u dv d alpha over v squared. They mean the same thing. So let's go ahead and do this. I'll leave that line there just for your reference. Alright, so let's go. What v is the bottom line, so I'll write it over here, right? So we have 13 minus 5 times the cos of alpha, that's v, times the differential of 5 times the sine of alpha, that becomes 5 times the cos of alpha. And we take away from that u, which is equal to 5 times the sine of alpha, times the differential of v. And of course 13 just dies, and you're going to get negative 5 times or positive 5 times the sine of alpha. Remember, when you differentiate cos, you get negative sine, and this negative again makes it a positive. And you divide all that by v squared, which I'm just going to say is 13 minus 5 times the cos of alpha, all to be squared. Now, just to make sure we're not confused, this is v, this is u prime. Prime, of course, by the way, means it's differentiated. This is u, v prime, and v squared. Alright? Now, because we're setting this to 0, we can get rid of that. If you just write equals 0 on the other side, you'll see that that just dies away. So what we're left is the following. And I'm going to use c and s for cos and sine. So it's just going to be a bit of algebra, nothing too mad at all. Alright? So the first thing is we're going to get 65 times the cos minus 25 times the cos squared minus 25 times the sine squared is equal to 0. And we know at this stage the cos squared plus sine squared is equal to 1. So this just turns out to be negative 25. And this turns out to be 65 times the cos is equal to 0. So the cos of alpha is equal to 25 over 65. And that's equal to 5 over 13. Alright, that was pretty straightforward. So the next part says, so like I said, that's pretty straightforward. Now we only got one value, so that means it can only have a maximum. Like if you're asking for minimum values, then we're getting into slightly more dodgy territory. And I won't talk about that because it involves something called the second derivative test. Anyway, so the next part of the question says, deduce that the time taken for a man to cross by the shortest part is 13 seconds. And to be honest, I'm actually going to leave that. And the reason I'm going to leave it is because I think this is the hardest part of the question. And if you can do that, then you're definitely flying into your A category for your Leaving Cert Applied Maths exam. So look, thanks for watching. Please pass it on to your friends and subscribe to my channel.